We got work to do. Make sure we're all in uniform here, lanyards. Guys, why am I having to remind you? Jake, you have a lanyard on? Can't tell with all that hair.
I know, I get it.
Alright, okay. Power function, exponential function, or neither. Anybody have an idea about any of them? Any thought at all about any of them? Lauren, what do you think? A is a power function. Very good, Lauren, because power functions are x to a power, right? Like x squared, x to the 8th. That is a power function. All right? B, on the other hand, is an exponential because the variable is the exponent. So 3 to the x, 2 to the x, 5 to the x, e to the x, those are exponentials. C and D are neither. C is all numbers, D is all letters, and to be a power function, you have to be x to a power, and to be exponential, you have to be a number to an x. Okay? Number 2, find the value of the function for the given x value without a calculator. So in other words, you want to figure out what is 3 times 5 to the 0. You know that. Anything to the 0 power is 1. Anything to the 0 power is 1. So this is 3 times 1, that's just 3. 6 times 3 to the x, oh, but x is -2. Now, stop and think a minute. What do those negative exponents mean? We talked about it way back, a long time ago, in August. What does a negative exponent mean? Eli?
It puts the coefficient in the denominator.
So instead of being 3 to the -2nd, it's going to be 1 over 3 squared. Remember, a negative exponent is 1 over. Now notice, the 6 didn't go down because the 6 does not have the negative exponent. Only the thing with the negative exponent goes down. So we've got 6 over 9, or 2/3. -2 times 3 to the 1/3. What does that mean? 3 to the 1/3. 9?
Isn't the cube of 3?
That's exactly what it is. Fractional exponents are radicals. Okay? Fractional exponents are radicals. And when you write the radical, the denominator of the fraction tells you what your root is. So if this were 1/2, it would be a square root. It's 1/3, so it's a cube root of that number. 1/4 would be a 4th root, and so on. So that's our answer. We can't really figure out what that is. And then 8 times 4 to the -3/2. All right, now don't panic, one step at a time. What do we do with negatives?
Send to the bottom.
Make it 1 over. So this is going to be 8 times 1 over 4 to the 3/2. Fractional exponents are radicals. So this is 8 times 1 over the square root of 4. Remember, the denominator of the fraction tells you what root you're taking. So this is a square root, but this time I have to cube it because there's a 3 up there. So this says the square root of 4 cubed. The square root of 4 cubed. Well, what is the square root of 4?
8.
Well, the square root of 4 is 2, but 2 cubed would be 8. So we have 8, the original 8, times 1 over 8. So the answer to that problem is 1. So the big things here are negative exponents mean 1 over, and it doesn't matter what the exponent is. It can be a fraction, it can be anything. If it's negative, it's 1 over. And then fractional exponents are radicals. The denominator of the fraction tells you which radical it is, cube root or whatever. So if we had x to the 4/5, this would be the 5th root of x to the 4th power. Right? Got it?
If you can't like reduce, or if you can't like square, like if it wasn't like a 4 like that, and it was like a 2 where you can't, like on the other
Oh,
problem.
here?
Yeah, if it was like a 2 where you can't, like, you know what I'm talking about?
Yeah, you have
You
to
just-
rationalize it.
Okay.
So we really aren't supposed to have radicals in the bottom.
Mm-hmm.
So if you were left with one, then yeah, you'd have to multiply by whatever to get rid of it. So if this is 1 over the square root of 2, you multiply by root 2 over 2 to, root 2 over root 2 to get it that. These ones with no calculator though, honestly, they're pretty much always gonna be ones you can do something with. Now, yesterday, remember I gave you 3 things. Gave you these, gave you your homework packet, and then did you notice I gave you an extra practice exponent paper? Okay, so I'm not requiring that, but
Pardon this interruption. There is a math in the chapel, and Father Domi would love for you to join if you have a recess or a free period right now. Thank you.
so if you want to practice some more with your exponents, you have that paper, and I think the answers are on the back. So you could run through some and flip it over and check, and you'll be all set. Okay. And you can talk about those as questions come up. All right, now number 3, write the equation of the exponential function where f of 0 is 3/2 and f of -2 is 1/8. This sounds a lot like a question we had not on yesterday's test, but the one before that. Write the equation of the linear function where f of something is something and f of something is something. What did we say? What do these represent? These are ordered pairs. And back then, we were writing the equation of a line. So we were ultimately shooting for y equals mx plus b. Well, now we're writing, same thing, points, but now we're writing an exponential function. An exponential function has something like this. The format is something like this. So you can have a number times another number raised to the x. Exponential means that has to be an x. So examples might be y equals 3 times 2 to the x. That's an exponential. Y equals -8 times 1/3 to the x. That's an exponential. Your job is to figure out what the a and b are that will generate those points. Always start with the one that has a 0. I promise I'm going to give you a 0 every time. Start with the one that has a 0. Because then your equation says this. Remember, this is x and this is y. There's a lot of letters there, but that's the x and that's the y. Now, why is that so good?
Because it gives you a 0.
Because b to the 0th is 1. So doesn't this say 3/2 equals a? In an exponential, A is called the initial value. In other words, that's the starting point. Well, notice if you graph this, isn't that also the y-intercept, guys? So the y-intercept is the initial value of the function, the starting point. If x is positive, we're going this way. If x is negative, we're going this way. All right, now that I've figured out what A is, my equation looks like this now. Yeah, 3F. Well, guess what I'm gonna do? I plugged in this point to get A, so what do you think I'm gonna do now? I'm gonna plug in my other point to get B. Now always remember, that's X and that's Y. So when you start plugging stuff in, X goes in for X and Y goes in for Y. Well, how in the world am I gonna solve that? Divide by 3/2, which is the same as multiplying by 2/3. So if I'm doing it without a calculator, I think I'll do that. And then, let's see, that would be 216 divided by 3. 72. So 72 equals B to the negative second. Is that right? Boy, I thought I rigged this better than that. I think that is a 3/2, right? Yeah. Well, this is not nice, but it is what it is. So what do I do now?
1 over B squared.
So 72 equals 1 over B squared, right? Because that's a negative exponent. Could we multiply to clear the fraction and then divide to get B by itself or almost by itself?
Yeah. That's what I would do.
And then to get B, I guess I'm gonna have to square root. So Jake, this is what you were talking about, because it didn't come out nice. Because someone did not plan it properly carefully, that would be me. So B equals 1 over the square root of 72, everybody okay with that? Now, 72 is 36 times 2. So that's 1 over 6 root 2. Don't get lost in the arithmetic. Square root of 72, 6 root 2. And then if I'm not allowed to have radicals in the bottom, I'll multiply the top and bottom by the square root of 2. And finally, after all that, B is going to be the square root of 2 over, this makes a 2, so 12. And my equation then, finally, is y equals 3/2 times root 2 over 12 to the x. Because my A was 3/2 and my B turned out to be that disaster. What's the matter?
Scary.
We're gonna do another one, and hopefully I planned better on the next one.
Can you explain what you did with, like, did you just plug the B back in once you got it?
My job is to write this equation. So I had to find the A and the B, and then I'm done. So now my equation has a y and an x. And the rest of it's my numbers. All right, let's try the next one. Let's see what happens here. We're gonna do the same thing. Our 2 points are 0, 3, and 2, 6. And our goal is this. In this chapter, we're gonna write two kinds of equations. We're gonna write exponentials and logistics. And these are going to be, this is the format for our exponential. So when it says write an exponential function, this is your starting point. All right, now what? Where do we go? We have to find A and B.
You plug in the first equation, so it's like
So you take this point right here.
3 equals,
So 3 equals A times B to the 0.
so this.
Well, what happens? A turns out to be 3. That's gonna happen every time. So I'm okay if you can remember that. You can kind of skip this step because that's always gonna be your initial value, always. So y equals 3 times b to the x. So now we gotta find b. We found a using this point. So now we will plug in, so 6 equals 3 times b squared. It's easier, but it's not as good as I'd hoped, but it's easier.
I have a question. Where's the b squared going when you set 3 equals a?
What?
Like where it says 3 equals a times b to whatever right there.
The 0.
Right here?
Yeah.
That's a 0.
Okay. My bad.
It's this point, Eli.
Oh.
So x is 0.
That makes sense. That makes sense.
So 2 equals b squared and b equals the square root of 2, which is perfectly okay. So my equation is y equals 3 times the square root of 2 to the x. That's it. All right, anybody have an issue with that? Sorry about the arithmetic here. Good? All right, the next part, this goes back, this is review for you. We are talking about describing the transformations of the basic function y equals 2 to the x. And then sketching these transformations. Now, I want you to think back. I know on your DFS, your exponential was y equals e to the x. Kids, it doesn't matter what the base is. So, can you remember what this looked like? What did this look like? Airdrop for me. Can anybody do that? What's it look like? It's the one that has an intersect at 1, an asymptote at y equals 0, and looks like that. That's your exponential. Now notice that if I let x be 0, this is going to be 1, right? Well, what happens if I change that to a 2? If I let x be 0, is that still 1? Kids, what's 2 to the 0? 2 to the 0, 1. It doesn't matter what the base is, well, as long as it's a positive number bigger than 1. So this can be 2, this can be 3, this can be 4, and this is going to be the general shape of the picture. Okay? Just like it was when it was e to the x. E is 2.7, so 2 is almost that. So this is the picture, your base picture. Do you remember what happens then with either one of these, with the changes that we made? Do you have any idea what happened with either one of these? Think back, way back, chapter 1. Anybody remember anything? Oh, you guys had a terrible teacher, apparently. You should remember this. All right, what happens when we change the sign on x? When we change the sign on x, we go from one side of the y-axis to the other. Here are the positive x's, here are the negative x's, right? When you change sign, you go across. So I'm gonna take that picture and fold it across the y-axis. That's what happens when you change the sign on x. You reflect across the y-axis. Does that sound at all familiar? Remotely,
Yeah.
sort of, like you
Yeah.
remember that now? So, changing the sign on the exponent turned my growth into a decay. Okay? I want to talk about this one more minute, and we'll do this one over here. 2 to the negative x. Is that the same as 1/2 to the positive x?
No.
Wouldn't this be 1/2 to the x? Now, if this is bothering you, the fact that I put that x involved with the 1 also, since that's a 1, tell me about 1 to any power. So, can't I say 1 to the x, and won't that still be 1? So yes, this and this are the same, because this is 1 to the x over 2 to the x, which is 1/2 to the x, right? So 2 to a negative power is the same as 1/2 to that same power, positive. Which means that not only am I decay if my exponent's negative, but I'm also decay, these are the same equation, I'm also decay if my base is a number less than 1. Okay, keep that stored somewhere. All right, what about this guy? What happens here? You took your x and subtracted 3. What does subtracting 3 from x do to your picture? Sideways shift, right? Which way is it going? X minus 3 goes right. So, remember, the only point, back to the original, the only point that we actually plotted was 0, 1. Well, now what's happening to that point? Now it's going to be 3, 1. Right, 3? Now, the asymptote hasn't changed. The only way the asymptote would change is if we lifted our picture up, then the asymptote would come up too, but we didn't, we shifted sideways, so the asymptote stays the same. So now we've got a picture that looks like that. Get these graphs done, and we'll be ready probably for lunch. Here we go. This is different than the one I just erased, because on the one I just erased, the x was negative. Now the function is negative. We put a negative out in front. What happens when you do that? It turns it upside down. So instead of having a curve up here, it's going to take it and reflect it across the x-axis. So the point 0, 1 is now going to be the point 0, -1, reflect it across the x-axis. A negative out in front flips you upside down. So if you take this exact picture, but flip it this way, can you visualize this? The asymptote hadn't changed. You just turn everything upside down. Try to remember the difference between a negative out in front, which is a reflection this way, a negative on the x itself, which is a reflection this way. What's another way of writing 0.5? 1/2. So a minute ago, I think I had this graph on the board, didn't I? What did we say about that? That's a decay. Wasn't that coming down like this?
Yeah.
Alright, so that's that right there. Remember, this is the same as 2 to the negative x. So you flip flop this way to get that. Now, what happens when you do +1? It's gonna take the entire picture and lift it up 1. Now, that's the entire thing. So instead of the asymptote being at 0, the asymptote is now going to be at 1. We're lifting the entire picture. And instead of the intercept, or the initial value, being at 0, 1, obviously now it's going to be at 0, 2. Now, the shape isn't going to change, so we're going to have this shape right here, just like we had, decreasing. But it looks like that now because of this and that. Are you sufficiently wowed?
Yes.
All right. Back at 48, in